So today I'm going to talk about how we do exactly once processing with Apex. So just a quick intro on Apex. So it's a stream processing engine. It runs on Hadoop. Basically, you write your applications in Java. You can write any custom logic you want. You build your streaming pipelines. Apex has some features. So it's scalable. Basically, each part of your application logic can be scaled independently and dynamically. It's fault tolerant, so any part of your processing, whatever state it has, Apex can recover it in case of failure and process it. There's also a library of commonly needed connectors and business logic that you can readily use. And there's a UI as well that's from DataTorrent, company I work for. So the bottom of the screen, you see a sample DAG or an application. So you take your the logic, entire application logic you want to achieve. You break it into smaller logical blocks, and you code each of them separately. So these are called operators, and you connect them up. And then each operator is emitting stream of data, which is received by the next operator. There's just two special operators. The first one is what we call input operators. So there's no operator before it, so it is responsible for bringing data from an external system. So for example, if it were talking to Kafka, so we would have a Kafka input operator. Similarly, the last operator is an output operator, which is writing to some external system. And each of these operators, you can have actually multiple partitions or multiple instances running distributedly on the cluster. So what does fault tolerance? So how does fault tolerance work, right? So each of your operator code can have state. So you can have aggregates or whatever it is that you're computing and you're keeping in your memory. So that's preserved. So periodically, the engine will serialize the state of your operator and save it to a persistent store. By default, it's HDFS, but you can change that. And on failure, and this checkpointing happens asynchronously and distributedly, right, using markers. And on a failure, the operator is restarted from the previous checkpoint, and the data is replayed from that checkpoint. So by default, that's the mode, that's at least once. But there's also another mode called at most once, where the latest data is given to the operator, in which case you'll have data loss. And then there is the end-to-end exactly once, which we'll go deeper into today. And that cannot be just done by the engine itself. So the engine working in coordination with the operators achieve exactly once. And there's also, Apex has an inbuilt buffering mechanism which supports incremental recovery of your pipeline. What it means is if you have a pipeline of 5 operators and then the third operator in this pipeline fails, only 3, 4, and 5 get affected. 1 and 2 continue to run wherever they are, so they don't have to get rolled back to checkpoint. And all this happens automatically, so there's no manual intervention needed. And if you are familiar with the Hadoop application architecture, there's an application master process that runs separately. And that's in charge of basically making sure everything's running properly. So its state is also checkpointed just in case it goes down, because it's also another container. So let's see how it works. So let's say you have a data stream that's coming in, and your operator is basically just summing up numbers. So within the data stream, Apex inserts these markers called window markers. So at the boundaries of these windows, different maintenance tasks happen. And typically, after some n windows, there's a checkpoint marker as well when the checkpoint happens. So let's say your data is coming in. You got, let's say, 3 numbers in the first window. So at the end of that window, so basically the operator is running continuously, right? And it's getting data continuously. So the sum is being computed all the time. But let's say at the end of the window, your sum basically reaches 7. And once your operator receives the checkpoint, the values sum 7 will automatically be saved by the engine, right? So you don't have to do anything special in your operator. Now, let's say you're processing window 2, and you got the first number 3, so sum became 10. And that's when something went down and your operator went down. So it'll be restarted back at the beginning of second window with sum 7. and the the next second window will be replayed, right? So what this guarantees is no data loss while processing, right? Because you're kind of going back to a previous state, and it's basically reprocessing data from there. So from here, how do you achieve exactly once, right? So what we define exactly once, or we call it end-to-end exactly once, is that your streaming pipeline produces correct results. The results that's kind of storing in an external system. It basically produces the correct results. There is no loss. There is no duplication, even in case of failures in your pipeline, right? So it actually requires three things. So one is the stateful recovery of operators, which the engine does. It requires an idempotent replay of data from your input operators. And I think the other speakers also talked about idempotent production. So this is similar to that. And then the output operator also needs to do something special, right? So in the next slides, I'll basically talk about some examples of a couple of output operators, how they basically make sure no duplicates are written in case of a failure. But for the input operators, for them to basically idempotently replay the data, it's not too hard. The Apex platform provides a utility called Window Data Manager, which the input operators can use to bookmark certain positions so that they can replay the same data in the same windows on a replay. So for example, the Kafka operator will store the offset of its stream every window. So it's not a lot of data, right? It's just the offset. So, and then let's look at a couple of examples of what the output operators need to do so that the entire processing is exactly once. So let's take the file case. So there's a file output operator that's writing the data to files. So by file here, it could be HDFS, it could be any files, even NFS, right? So as data is coming in, it's basically writing data to the file, but it keeps the offset of the file in its memory. So that's the state. So the offset gets checkpointed, right? So let's say checkpoints are happening periodically, and let's say the bottom one is the latest checkpoint, and some more data came in. So another checkpoint happened, and older checkpoints are purged as soon as the entire pipeline has checkpointed at the same point. So now let's say you process some more data, and then there's a failure, right? At this point, what the engine will do is it'll restart your operator back at the third checkpoint, right? In the third arrow. So, but the file has extra data, right? So what the operator does when it comes back, it truncates the file back to that offset, because the offset value was restored by the checkpoint recovery. It just basically changes it basically removes some extra content from the file so that the file's state is consistent with its own offset state, right? And HDFS truncate is not so simple, so it's actually doing a copy internally, right? And then it starts writing data again. So that way, ensure that there are no duplicates in the file. So let's take the example of a database output operator. So this operator is basically writing data into some tables. So what it does is, along with the data, so it writes the data in a window in a single transaction. So either the entire data in the window is written or is committed or not, right? But apart from that, it also writes the window ID, which I showed you earlier, right? There's a window markers. So each window has an ID. So it also writes the window ID into a meta table. So the reason is, what happens is on a replay, the engine will start the operator back at the checkpoint, right? So when it starts back at the checkpoint, but data from checkpoint to window N is already been written to the table, right? So we don't want to write it again. So the operator, what it does is it ignores the data. As soon as it restarts, it reads the meta table back. So it gets the window ID back from the meta table, and it ignores the data from the checkpoint to that window so that there are no duplicates in the output store. And then it starts writing the next windows normally. Okay. And that's it. Some resources here, and I think we can have question and answers.